Hi, I'm Davide, and today I'll present our work on personalized face anti-spoofing in collaboration with Debasmit, Bence, Fatih in Qualcomm AI research. In face anti-spoofing, the task is to classify a face image between live and spoof classes. Existing solutions consist of deep learning model trained on large datasets collected over different subject, sensor, spoof types, and other conditions. At inference time, the anti-spoofing model outputs a prediction per sample without knowledge of the current subject or sensor. We propose instead a personalized solution to make the prediction aware of the subject and sensor. This idea comes from the observation that in real application, the anti-spoofing system is usually paired with a user recognition system, which relies on enrollment data. Enrollment data is a collection of live samples from the given subject, which are used for identification. We argue that enrollment data can also be useful for anti-spoofing, and thus we suggest to adopt the face anti-spoofing benchmark to account for its existence. In our work, we first introduce a simple method to adapt existing datasets by introducing enrollment sets paired with each sample. An enrollment set describes a specific subject interacting with a specific device, as in a real scenario. While in the original dataset, a sample is described by the queried image and its label, as described here, we construct a personalized version of the dataset in which the sample is also including an enrollment set, a collection of live images from the same subject and sensor. This can be used as an additional input for the training of anti-spoofing models. We apply this conversion method to two of the latest face anti-spoofing datasets, cell-based spoof and SIW. In these examples, we can see how the enrollment sets represent each subject, under different lighting and poses, which can be useful reference for the classification of unlabeled live and spoof samples. We show some cases for cell-based spoof and for SIW, and also the population of samples in our splits. We then introduce a few baselines to evaluate the effectiveness of personalization for face anti-spoofing. In our approach, we add the enrollment data as an extra input to the model. First, query and enrollment images are separately encoded through a feature extractor. Then, the enrollment features are combined with an aggregation function. In our experiments, we investigate different implementations for this aggregation function, including non-parametric ones like concatenation and mean, and learnable ones like GRU, attention, and GNNs. We finally evaluate our personalized approach and observe an improvement in performance against non-personalized baselines across different datasets and backbones. We also conduct a few ablation studies. Firstly, we compare various aggregation methods and notice how simple functions like mean and concatenation are actually overperforming more expressive ones like recurrent networks and GNNs in the case of our datasets. We tried an ablated version of our personalized model in which the query and enrollment features extractors have shared weights, in this case, the CNNs. The performance decay when using shared weight suggests that the network tries to extract different type of information between query and enrollment images, which is allowed when using the separated weights, as in our default method. To conclude, we also observe that having multiple images per enrollment set is beneficial for anti-spoofing, as they provide more information about the subject. In the datasets we experimented with, 2 and 4 images are enough, but we argue that optimal hyperparameter choice depends on the variability of enrollment set images in a given dataset. Thank you for your attention, and we look forward to meeting you during the poster session.